All right, hello everybody. Today we're going to look at mathematical vectors. So far we've been looking at the graphical way to solve these. So we've been using a scale and a protractor and that sort of thing, and drawing everything to scale on that paper. Today we switch gears. We're going to solve the same type of problems, but now we're going to switch to mathematical techniques. And so some of you guys will like this better. It's faster. It's a little more surefire in terms of us all arriving at the same answer and that sort of thing. Maybe not quite as fun. You still are going to do a rough sketch. And so our little sketch techniques, our tip to tail techniques that we've learned are still going to be really important. So the stuff that we learned before, still completely applicable here with the mathematical vectors. With these, we're only going to deal with right angle displacements and velocities and accelerations. If you remember with the graphical techniques, we were able to do things that didn't meet up at right triangles, but with the math, that's going to kind of be our limit, is solving things out that are completely right triangles. So since they're right triangles, that means that we can use certain methods and techniques to solve. The first of those being the Pythagorean theorem, which you guys have seen plenty of times in the past, maybe not for a while, but here it is. Remember, this is for right triangles only. So we're going to be looking at something like this. Like we might have some kind of a displacement and then another displacement. Looks a lot like our graphical techniques. And then we're still going to have our resultant drawn in. It's just a matter that this took 10 seconds to draw versus when we did these graphically, this would take 5 minutes to draw maybe, once we would scale everything out. So this is that's kind of the change. You'll still draw this. You'll still be able to label your sides and all of that, like we could do that now. There's C. A and B, doesn't matter which side you'd call A or which side you'd call B for Pythagorean. But there's your setup. The angle still going to be back at the beginning of the problem, if you remember that. So back at the beginning of the problem and then solving for this angle. We did it with a protractor before, but now you're going to actually calculate it out. So that's kind of the change. With Pythagorean, remember if you are solving for the hypotenuse, that this is set up so that this part's squared. So you do still have to do a little bit of rearrange just to get that by itself. And then of course you could solve for one of the sides as well, just by subtracting across. So maybe we could look at something like that. So you could do c squared minus a squared equals b, and then you'd just be taking the square root of that. So that would be one of the sides if you had to solve for one of those. So anyway, that's very handy. The other thing when it comes to solving the angles, so this will deal just with the sides, but dealing with the angles, that's where we're going to use sine, cosine, and tangent. So sine, cosine, and tangent. These things, that's an A, although it doesn't look that way. Those, if you guys remember the saying, SOHCAHTOA, whatever it is you need to do to remember these, you'll have them in front of you when you're taking a test or a quiz or that sort of thing. But this was sine, cosine, tangent. Just depending on the sides that you have, this will help you to solve the angles. And we'll run through an example to kind of show you that. But just remembering, here's hypotenuse. The opposite side is the one that doesn't touch the angle. And then the adjacent side is the one that touches the angle, but is not the hypotenuse. So that'll help you kind of decide which of these is going to help you to solve the angle. We'll maybe go through an example and draw one of these out so you guys can check calculator work and make sure that this all makes some sense. Let's just say we've got somebody that's walking north. Let's just make up numbers here. Let's call it 16 meters north. And then let's have them turn east. And let's have them walk 11 meters east. And maybe that's the end of the problem. It just wants the resultant displacement. And so we've drawn tip to tail. We've done exactly what we were supposed to. We're ready to draw the resultant, which I'll draw right now. There's resultant. And we're going to need to solve for this side and back to the beginning of the problem to solve for the angle as well, to describe this vector that we're talking about right here. And so we're just going to run Pythagorean theorem to solve here. So I'll set that up so you can see it. Pretty easy to do. And we're going to type this in. And we're coming up with the hypotenuse side there of 19 meters, sticking with our 2 sig figs. All right, and then for our angle, we've got options now because we know every single one of the sides. So we could actually use sine, cosine, or tangent, and maybe we'll do a couple of them just to kind of show you. What I would recommend, because these numbers, 16 and 11, are in the problem, we know they're right. And so tangent's probably the one that you would want to use because you know the values that you're plugging in here and here are correct. If you use sine or cosine, you notice both of those use hypotenuse. We solved it. There's the hypotenuse. But what happens if we made a mistake here? The problem would be is that we would guarantee that our angle would also be wrong. So it's probably safest in this case to use tangent. Like I said, maybe I'll walk you through using a couple of them just so you can see that they'll come out the same. But let's do tangent, and I'll show you the way this gets written. We write tangent, and we're trying to solve the angle, which is theta. So tangent of our angle theta is exactly as it is here, opposite over adjacent. Well, opposite is 11, and adjacent is 16. So sounds like 11 over 16 is our setup. We have to solve for theta, which means basically we have to divide by tangent. And to do that, we have to use the inverse. That's the way that you divide by tangent. So on your calculator, you need to use this button, which usually means hitting like a second key or a shift key, or just depending on your make and model, something like that. It may have you entering like this first, and then you would just do 11 over 16. And hit equals. Probably going to need some parentheses in there. It usually brings up like a parenthesis bracket right there. Some calculators, you have to kind of do this manually. Enter this first, get a value, and then just hit inverse tangent. Either way, we'll work this out so you know what you're working towards. So you should get an angle here. We can write it right here of, once you round to 2 sig figs, 35 degrees. So if you get 35, then your entry was good. If you don't get 35, double check it. You do have to make sure that your calculator is in degree mode. So definitely look for it to say DEG. You don't want rad, and you don't want grad. So if you're getting weird numbers and you feel like you're doing everything right, check the mode of your calculator. You want either degree, you want degree mode, not either of the other two. So be careful with that. All right, almost done here. The last thing, remember, we have to describe where we measure that angle from. And in this problem, here's our angle. Here's the line that it's measured from, and this is north. And then to get to our vector, we go east. So we're going to call this north of east, like we have been doing. North of east. So everything we need, if I can box this in, it's going to be a strange box, but I think I can do it. Everything we need is right there. That's the complete answer to this this made-up example problem, but hopefully allows you to kind of make your way through. Let's do as the last thing, let's just say we would have used cosine down here instead. So in other words, we wanted to do cosine of our angle. Cosine is adjacent over hypotenuse. So here's this, here's adjacent. And so we're going to do 16 over what we solved, which was the hypotenuse of 19. So this is adjacent over hypotenuse. Remember, there's a little bit of risk here because if we goofed here, then this number's guaranteed to be off as well. We're going to use, remember, if you're solving for the angle, you always use the inverse button. So we're going to have to use inverse cosine. But let's go ahead and run this and make sure that math is working. Looks like it's going to do all right. Yeah, with sigs. Because there's some rounding here, this is going to kick out as 33 degrees. Still north of east. Still 100% right, north of east. But because there was some sig fig rounding with the 19, that's what makes this look a little bit different. But both are fine. Okay, hopefully that helps.